Welcome to another Intermediate Algebra video. In this video, we'll look at dividing polynomials by monomials and polynomials. Which leads to our two objectives, which are exactly as I mentioned, dividing a polynomial by either a monomial or a polynomial. And we'll have two different strategies for each of them. If we're dividing a polynomial by a monomial, which means one term, our strategy will be to break it into separate fractions and then individually simplify each fraction. If we're dividing a polynomial by a polynomial, where we have many terms, we'll use long division. Long division with a polynomial. You may not have seen this before, you may have seen it before. The monomial is the much easier of the two, so that's where we'll start. Do some problems together, practice, and then we'll go into the long division. All right, so here's our first problem. This problem is presented to you with the division symbol, and we can see that we are dividing, as the objective says, a polynomial, which just means many terms added and subtracted, by a monomial, one term. Another way of viewing the division symbol is as a fraction. Sometimes it's preferable to see it with the sign itself, sometimes as a fraction. In this case, as a fraction will be better. The whole thing is divided by 5x. So, we had a couple different strategies thus far for if the direction said simplify for a problem like this. Maybe you'd factor, but this one says divide. That's the important thing. When it says divide, and we're dividing by one term, we're going to break this into separate fractions and then simplify. So, it's very tempting to say, hey, here's a 5 and here's a 5, here's an x, cross them out, but it needs to be multiplication. So, this is a different way of doing it. Take each term and write it with the 5x dividing it, breaking it into these separate fractions. This is an okay thing to do because if we were to go from this line back to the previous line, we would say, well, they're all fractions with the same denominator, so pull them together to have that denominator and just combine the numerators. So this is definitely an okay thing to do. It's just not typically something that we do. Okay, so break it into separate fractions and then individually simplify each one. So the first fraction, 10 over 5, simplifies to 2, x cubed over x, simplifies to x squared. There are 3 x's on top, 1 on the bottom, 1 and 1 cancel, we have 2 left on top. Nothing really left on the bottom means you don't have to write the denominator. All right, the second fraction is being subtracted. 5 over 5 gives you 1, and then x squared over x, 1 and 1 cancel, you have 1 left. Nothing on the bottom. Plus our last fraction, 20 over 5 simplifies to 4, and then a single x over a single x, both cancel out, and there's no variable left. So you can write this as 2x squared minus 1x, or just minus x, plus 4. Either one, completely fine. So that's that's dividing polynomial by monomial. Let's do another one. This one's already presented with the fraction bar. If it's presented with the division symbol, you just set it up this way, but the directions saying divide are what tell you to follow this method. So, break it apart into separate fractions. We'll have 4 fractions. Because we have 4 terms in the numerator. Then simplify each fraction individually. So the first fraction, 3 over 1, we have 3 left. 5 x's on top, 2 on the bottom. 2 and 2 cancel. We're left with 3. 3 x's. Y squared over y, we're left with a single y. Nothing on the bottom. Minus 15 over 1, we still have 15. X cubed over x squared, 3 and 2 and 2 gone, we're left with 1 on top. And y over y gone. Minus, we have x squared over x squared and y over y. So what's left there? None of the variables are there, but remember these coefficients are still 1 and 1. What's 1 over 1? 1. You still need that placeholder. We're not changing any information, we're just manipulating it, looking at it a different way. So we need that placeholder of 1 to be able to go back to our previous line. And then the last piece, we have a 6, we have an x, and 2 x's on the bottom, 1 and 1 cancel, and there's 1 x left, but where is it? This is important. The x in this piece is in the denominator, and so it must stay in the denominator. And the y, there's nothing to cancel it with, it is also in the denominator. This is the reason the strategy of factoring and then canceling things out, while it's another viable way of simplifying, it doesn't give you the type of answer we're looking for here. If it says divide, this is what you're supposed to do with it. So here is our polynomial divided by monomial. Again, this whole thing. Polynomial and monomial. The most common mistakes would be on this third fraction, writing a 0 or not writing anything because it looks like everything cancels, and it does, but there's still a placeholder of a 1. And then on the last fraction, common mistake would be writing the x and the y up top. They are in the denominator, and so they must stay there. So this is dividing polynomial by monomial, by one term. Let's practice that quickly, and then we'll move on to dividing by a polynomial. So go ahead and pause the video, run through this problem on your own, and we will go through it together in a moment. Okay, so let's break this apart. We're dividing by a monomial, and you don't have to write that ever when you're working the problem out. Just want you to recognize what it is. Break this into 4 separate fractions. For this one, it's 4 separate fractions. It's also very tempting for these problems not to do this step and just try to simplify, just try to simplify from the given problem. I would strongly encourage you to write this line out. It takes another 15 seconds, but it helps you to very clearly be able to simplify. If you need the visual aspect, then this is the way you're going to have less errors, is simplifying this way. That's a B. Let's fix that. B. Okay, so simplify each one individually. The first one, we have 5a squared with a b. Ooh, my mistake. There we go. B to the 4th over b squared left. The second fraction, we have 8, a single a and a single b. The third fraction, placeholder of 1, all variables go away. And the last piece, we have 8, a and b. Good. So this is dividing polynomial, a bunch of terms, by monomial, one term. Okay, now we look at dividing polynomial by a polynomial. More than one term. So I'm going to draw the parallel for you back to long division when you first started in math. So let's say we want to look at 12,468 divided by 11. if you were to do this problem by hand, if I told you not in the calculator, because obviously you could type it in the calculator, I want you to divide this by hand. How would you set it up? You'd make the little house. And if you were doing math in another country, there's a good chance your setup structure was a little bit different. That's fine. Most definitely keep using your strategy if you want to, or you can use the one here. The same strategy that applies for the numbers will apply to the polynomials, so you'll be able to do exactly the same thing. All right, so when we set it up like this, the 11 was on the outside, the thing we were dividing by was on the outside, and then the initial piece was on the inside, under the house. So we're going to do them both simultaneously. So let's set up the same thing for our problem. Actually, let's move this down a little bit. So we have the x plus 2 on the outside. Oh my goodness. And 2x squared minus x minus 10 on the inside. Okay, so let's go back to our number problem. How would we actually start working this out? First, we would ignore all these numbers at the end. We would look just at the 1, and we would say, is there anything we can multiply 11 by to get 1? If the answer was no, we slide our focus over. How about 12? Anything we can multiply 11 by to get 12? Here, the answer is yes. That number is 1. So we write that number up top. Then what happens? Then we took 1, we multiplied it by 11, wrote that underneath the 12, and this is the biggest piece. We subtract it. All right. Pause on the numbers. Let's go back to our problem. So we focus on the x. The plus 2 will come into play, but it's not the point of focus for the moment. And we start the same way. Focus just on the first piece, 2x squared. Is there anything we can multiply by x to get 2x squared? Yes. 2 times x would give us 2x squared. So we write 2x up top, just like we wrote 1 up top. Once we decide what we're multiplying by, we write it up top. All right, then what happens next? In our numbers, we multiply 1 times 11. So do the same thing here. 2x times the entire quantity. 2x times x is 2x squared. 2x times 2 is plus 4. Okay, then the most important piece, the piece that in this long division is most commonly, a mistake is most commonly made with, is the subtraction part. This whole thing gets subtracted. Just like the 11 gets subtracted, this whole thing gets subtracted. So when this negative gets distributed, I'm going to fill it in individually. It becomes minus 2x squared and minus 4. I'm going to circle the sign that actually will be used with the simplifying. So you do the multiplication as usual, 2x times x, 2x times 2. Get those items. And then subtract them. So ultimately it becomes the opposite sign. Okay, so then we actually did subtract. 2x squared minus 2x squared is gone. That's why we chose 2x. That was the whole goal. We're trying to get rid of piece by piece. Then negative x, oh, this is x, plus 4x. Negative x plus 4x, oh, not plus, minus. Negative x minus 4x minus 5x. Okay, so we're at the same place in our number and polynomial problem. Go back to the number. What happened next? Then we brought down the 4 and start all over again, right? Same thing over here. Bring down the negative 10, and truthfully, anything else that remains, start over again. So back to our number. What times 11 could give us close to 14? The answer is 1. So we wrote it up top. We multiply, and then we subtract. Same thing for our problem here. What can we multiply x by to get negative 5x? The answer, negative 5. Now we take negative 5 and multiply it by x plus 2, which gives us negative 5x and minus 10. But all of that gets subtracted. So each sign changes. Plus is the ultimate sign, plus is the ultimate sign. And now actually combine. Negative 5x plus 5x, gone. Negative 10 plus 10, gone. Nothing left over. Now in our number problem, we would get to a point, if we keep going. Sure, we'll keep going. Bring down the 8. Oh, 8. We get to a point where we had a remainder. In this problem, we didn't have a remainder. Our answer is 2x minus 5. And you might be wondering, move over. You might be wondering, well, couldn't I just factor 2x squared minus x minus 10, cancel out the x plus 2 and get 2x minus 5? For this problem, yes, but not every problem will work out that way. So if it's explicitly written with a division symbol or the directions say divide, then this is the method you'll want to use. And it may even say divide using polynomial long division. You might also be wondering if you can use the method of synthetic division. If you know how to use that method, for this problem it would work because the term we divided by, first of all, the x was to the first power, and second of all, it didn't have a coefficient. But not every problem will work like that. So the overall method that works for everything is polynomial long division, and that's why we're going to continue to use this method. So this one didn't have a remainder, so this is our answer. If it did have a remainder, like this problem right here, there were a couple strategies we used to fix that. You could either add a decimal, keep going forever and ever, or sometimes we wrote remainder 5, or sometimes we wrote this as a fraction and 5/11. The number problem would not ever be one you'd be asked to do, but draw the parallel with me. So when we divide by 11, we get 1,133 and 5/11. If we were to get a remainder, something that we couldn't multiply x to undo, this is how we're going to write it, with a remainder. Not with a remainder, with the fraction. Whatever's left over the thing we divided by. In that case, 11, here x plus 2. All right, let's see another one. Next one, 6x squared minus 19x plus 12 divided by 3x minus 5. Synthetic division would not work for this one. Polynomial division is the only route. So we set up 3x minus 5 on the outside, and the 6x squared minus 19x plus 12 on the inside. Okay, and we're looking for something to multiply. It's always the first piece of that polynomial that we focus on. Something to multiply by 3x to get 6x squared. Definitely a 2 and an x. The placement of your items on top of this division bar, or this little division house, don't necessarily matter. My strategy is to put them over the term that they correspond with. So this is an x term, I'm writing it over the x term. You don't have to follow that strategy. You'll still get the same answer if you don't. All right, so then multiply this 2x by 3x minus 5. We get 6x squared minus 10x. Don't forget, these get subtracted, which means their signs change. Now combine. 6x squared minus 6x squared, gone. That's the whole reason you chose 2x. Negative 19x plus 10x. Negative 9x. Bring down the 12. Plus 12. Start all over again. What can you multiply 3x by to get negative 9x? Negative 3. Actually multiply it negative 9x plus 15. Don't forget, each of these signs changes. Circling them is a good way to remind yourself and to point out which one is the actual most important sign. Combine negative 9x plus 9x gone, positive 12 minus 15, negative 3. Then try again. Is there anything you can multiply 3x by to get negative 3? Technically, yes, but not anything that we're going to look at. If it's not something that jumps out to you, we're not using negative exponents, so that would not be part of the answer. Okay, so just like we looked at in the last slide, this is sort of a remainder, sort of. So we'll write it as the piece that we got through the long division. And in this case, it's all added together or subtracted, but we're going to go with addition. The thing we have left over the thing we divided by. Just like on that last slide, we had 5/11ths. We have plus negative 3 over 3x minus 5. Because this problem, the remainder piece, is negative and it's the only piece, another way you could write this is like this. You could write 2x minus 3, same beginning, but instead of plus negative 3, you could just write minus 3 over 3x minus 5. Either one's okay, and you might be thinking, well, the second one looks more clear to me, but I would encourage you to go with the first one because this problem only has one piece left over. If there were multiple pieces there and you used the second answer, you would have to pull the negative, sort of factor it out of every piece of the numerator. So to avoid having to do that, you just write plus whatever's left over divided by the thing you were dividing by. So either one of these presentations is good. All right, let's see another one. Good. One more with me. You might feel confident and ready to go, but this is it's the same strategy, but there's a couple, curveballs thrown in here. So I want to do one more together. So we have 3x to the fourth plus 2x cubed minus 8x plus 6 divided by x squared minus 1. The setup is the same. 3x to the fourth plus 2x cubed. And maybe you notice this, maybe not, but if we look at this first polynomial, we have x to the fourth, x to the third. We don't have an x squared term. So I'm going to leave a space for it. You don't have to, but it helps you to stay organized if you do. So we don't have an x squared term. We do have the x term and our number term in this descending order. Now, for the thing we divide by, we have x squared. We don't have an x, but you don't really need the space there. You do a lot of work underneath this division house, so the space is helpful.